The CVP-1 from Low-Gain Electronics is an 8 HP Eurorack format module. It is comprised of two channels, Channel A and Channel B. Each channel features one input for Channel A, input for Channel B. The inputs for each channel are normaled to a 5-volt DC voltage source. Three outputs. Output 1 for Channel A, 2 for Channel A, 3 for Channel A. 1 for Channel B, 2 for Channel B, and 3 for Channel B. Each output features a unity gain attenuverter. This is the attenuverter for the first output of Channel A, second output of Channel A, third output of Channel A, first output of Channel B, second output of Channel B, and the third output of Channel B. I am going to demonstrate the effect of attenuversion on the voltage's output from the CVP-1, as well as the third output interactions with the OR and some outputs made available on the front of the panel. Each channel of the CVP-1 features an input normaled to a 5-volt DC source. If you have no signal going into either input for either channel, the attenuverters will be accepting that 5-volt DC source. If I turn the third output attenuverter fully clockwise, 3A will output positive 5 volts. If I turn the third attenuverter for channel A fully counterclockwise, 3A will output negative 5 volts. If I turn the third attenuverter for channel A to the noon position, output 3A will be 0 volts. Now, we're gonna have fun with some waveforms. I'm going to be inserting a ramp wave from an SSL modulation orgy into the input for channel A. If I turn the third attenuverter for channel A fully clockwise, you will see a reproduction of that ramp waveform. If I turn the third attenuverter for channel A fully counterclockwise, you will see an inverted version of that ramp waveform. If I turn the third attenuverter for channel A to the noon position, there will be no ramp waveform on output 3A. Let's keep the waveform party rolling. Into channel B of the CVP-1, I am sending a weird wanted in multiple county LFO generated by a mutable instrument's tides. If I turn the third attenuverter for channel B fully clockwise, you will see a reproduction of that LFO. If I turn the third attenuverter for channel B fully counterclockwise, you will see an inverted version of that wacky waveform. If I turn the third attenuverter for channel B to the noon position, there will be no more wacky wild waveform. The OR output of the CVP-1 is a reproduction of the highest positive voltage by comparing both 3A and 3B post-attenuversion. If I turn the third output for channel A fully clockwise, you will see the positive portion of the ramp waveform. Note how the ramp waveform seems cut off at 0 volts. That is because the ramp LFO goes from negative 5 volts all the way to positive 5. Everything below 0 volts is disregarded. This is called half-wave rectification. Now, if I turn the third attenuverter for channel B fully counterclockwise, we will be comparing this half-wave rectified ramp LFO against a half-wave rectified wacky LFO. If I turn the third attenuverter for channel A to noon, you will see what the half-wave rectified version of just that wacky LFO looks like. The sum output of the CVP-1 is a unity gain mix comprised of the outputs 3A and 3B post-attenuversion. If I turn the third attenuverter for channel A fully clockwise, the sum will be receiving and reproducing the ramp waveform. If I turn the third attenuverter for channel B fully clockwise, the sum will be a combination of the ramp waveform as well as the weird and wacky LFO. If I turn the third attenuverter for channel A fully counterclockwise, the sum will be a combination of the inverted ramp waveform as well as the wacky LFO. If I turn the third attenuverter for channel B fully counterclockwise, the sum output will be a combination of the inverted ramp as well as an inverted version of the wacky LFO. In this patch, I have a ramp LFO generated by a Synthetic Sound Labs modulation orgy, as well as a weird LFO generated by Immutable Instruments Tides. The ramp LFO is going into the input for channel A. The Mutable Instruments LFO is going into the input for channel B. The sound source for this demo will be coming from a Richter Maleko Oscillator 2 and a Richter Maleko Anti-Oscillator, both being processed by independent Circuit Abbey impulse drives. Each impulse drive features 3 outputs. Those 3 outputs are both going into 3 inputs of a submix 6. For instance, the left impulse drive is going into inputs 1, 2, and 3A of the submix 6, while the right impulse drive is going into inputs 1, 2, and 3B of the same submix 6. Mix A of the submix 6 is then going into input 1A of a WMD microhadron collider. Mix B of the same submix 6 is going into input 2A of the WMD microhadron collider. The microhadron collider is set in parallel, so each impulse drive will be going through its own bandpass filter. Output 1 of the microhadron collider is going into the first audio input of a ZDSP by Tip Top Audio. Output 2 of the microhadron collider is going into the second audio input of the same Tip Top Audio ZDSP. The ZDSP is then going right into the DAW. Channel A of the CVP-1 is controlling the impulse drive for the left channel, as well as the filter frequency for the left channel on the microhadron collider, and the analog feedback for the first audio input on the ZDSP. Channel B of the CVP-1 is controlling the impulse drive for the left channel, as well as the filter frequency on the microhadron collider for the left channel. It is also controlling the analog feedback on the first audio input of the ZDSP. Now, let's bring in the sound with no voltage being output from the CVP-1. Now, let's start adjusting the attenuverters for channel A of the CVP-1. Now, let's start adjusting the attenuverters for channel B of the CVP-1. Now that we have completely and totally destroyed the original signal, let's bring the attenuverters back to noon. Since the CVP-1 can process audio signals, another use is as a send module. Just off screen, I have a number of modules patched up to make a drum program. I've got a kick drum. I've also got a snare drum. And then, for good measure, I've got freak out robotic gibberish. That mix is going into a buffered mult. One of the outputs from that buffered mult is going directly into the DAW. That will be our dry mix. One of the other outputs from that mult is going into the input for channel B of the CVP-1. The three outputs for channel B of the CVP-1 are routed as follows. The first output for channel B is going into a Flight of Harmony Sound of Shadows, which is then being processed by a WMD Geiger counter. Let's listen to some of that now. Output 2 of channel B is then going into a ZDSP by Tip Top Audio, which is being processed by a Flight of Harmony Plague Bearer. Output 3 of the CVP-1 is going into a Harvestman Electronics Time Safari, which is being processed by a WMD Micro Hadron Collider. In this configuration, the CVP-1 is controlling the send levels through these three routing paths. Let's just wiggle for a little bit. Also, when you invert any of the outputs when handling audio on the CVP-1, the result will be phase inverted.